All right, ladies and gentlemen, recording has started. So, tomorrow we have tests over our work and energy unit. Work and energy unit started all the way back on Monday, March 12th, which was the beginning of OGT week. I realized that was kind of a short week, blah, blah, blah. There were basically three parts to this. There were basically three parts to this unit. The first part, we introduced the different kinds of mechanical energy. We started off with kinetic energy, and then we talked about gravitational potential. We talked about elastic potential. That was the first part of this unit, introducing those different forms of energy. And we talked about that energy is the ability to change stuff, to make things different than they were before. And these are three different kinds of mechanical energy that we deal with most often. Then, Friday of that week, you had your first quiz. That was the one that I just handed back to some of you. Some of you must have picked it up earlier than that. I believe it says Introduction to Kinetic and Potential Energy. Okay. Where we're just going through and calculating what kind of energy there is, how much kinetic energy does this have. We talked about relationships within the formulas that, here, hold on. Sorry. Should put this on. Stand by. I'm opening up the drawing, the notebook programs. Like right on the board.
Kinetic and potential, is that this one?
Yeah, that's the first part.
Set.
Yep.
Yeah.
Is this just a voice recording, or is it recorded?
It records the screen. So you can hear it. So you can hear me talk. And you'll see.
You know what I figured out yesterday? The copy, like the picture, like I could just let's say Control Alt and something else, and you can copy it and paste it. Never knew how to do that.
Like the whole screen.
Yeah.
Oh yeah.
I didn't know how to do that. Just figured it out.
Nice.
It's exciting. Good moment.
All right. You no longer have to stand by anymore. Here we go. So, kinetic energy. We talked about the kinetic energy depends on a couple of things, right? They talked about mass and velocity, but we're squaring the velocity, right? So doubling the velocity results in 4 times as much kinetic energy in that object. If we triple the velocity, it results in 9 times as much kinetic energy because of the squared velocity term in there, right? But we also talked about the gravitational potential energy, depending on 3 things: the mass, the acceleration of gravity being 9.81, not negative 9.81, because energy is a scalar quantity, so it doesn't have directions. We don't have to make the 9.81 negative. It's just the acceleration value. And then the height value, right? We said the important part there being that we have to pick our reference points, but the moral of that story being, does it really matter where we pick the reference points? If we're talking about an individual calculation, yes. But if we're talking about something moving from one height to another height, if that object is changing heights, does it matter where we put the reference point? It doesn't. Okay. And on your quiz, there was that one problem with the hill people and the valley people, right? They keeps coming up over and over. Yes. Yes. It does keep showing up. So actually, Jesse, one of the points that was quiz. So I shall wait and see. This guy people in the room. But Jesse, one of the points being though that when we deal with the energy stuff, we're looking at the same kinds of things, just looking at explaining them in a different way. So instead of gravity causing a certain acceleration going to make that velocity when it hits the ground using a kinematic equation, if we talk about that it starts with potential energy and ends with kinetic energy, we can get to that same number just going about it in a different way. We said that depending on the situation, sometimes it's easier to use energy, sometimes it's easier to use kinematics and stuff like that, depending on what we're looking for. All right, and then one last thing we talked about elastic potential energy, and elastic potential energy being 1/2 kx squared, right? Where the x value,
Hell, you can't. Here.
Tom's not here, right? She said she showed up this morning. She had to go down to the case to get help. All right, so when we talk about elastic potential energy, two things. The K value standing for the spring constant, which is a description of the material that's springiness, or whatever it is, okay? But then the X value, we said, was the difference between how long was the spring before we stretched it and how long is it now? Or basically how far we stretched it. Not the total length at the end. That's the delta. Yeah, I guess you could do delta X, that would be fine. Yeah, you could think of it that way. That would be fine. So, yeah, because you really want the change in the length. That's really what we're looking for. Good there? As far as problem sets go, you did have one problem set in this. Pull it up so you can see what it looks like. Oh, that's not what I wanted. That's not good. Maybe I won't pull it up because it's gone now. There it is. Probably should have had this ready to go.
Nah.
But watching me fumble up here.
There's so many folders.
Yeah,
Oh, I know.
don't worry, I got it under control though. So.
Oh, you're
I know exactly where to get everything. So. I made it folders. Exactly. I blame that on the pen, not me. See, I mean, this is incentive to go back and watch this. It's really just kind of entertaining.
Yes.
Yes. See, that's why I do this for you guys. I'm not really interested in kind of just for you know. So, first problem set: kinetic and potential energy. That's what it looks like. Answers to that problem set are posted online. So, key numbers here. Well, we talked about. Rachel, from a conceptual standpoint, right? Number 1 and number 2 give you like the relationship between velocity and kinetic energy, right? That you need to square the velocity, and that gives you the kinetic energy, right? In the beginning, we talked a little bit about the relationship between one type of energy and another type of energy. That's a little bit more conservation. We'll get into that a little bit later on. But a lot of this page is a lot of simple plug and chug sort of problems. You know, a lot of, you know, this is the mass, this is the velocity, what's the kinetic energy? But along with this, the first quiz that we took that says Introduction to Kinetic and Potential Energy on it, that's got a lot of multiple choice, conceptual kind of questions that will show up on the test. So, you don't have that page? Quizzes, problem sets. There should be 3 problem sets here. Yes. 4 problem sets. Sorry, there's 4 problem sets. There's one that's show you kinetic potential energy. It looks like this. I can get you a copy of it.
And what's the last problem set?
So there are 4. Sorry, there are 4 problem sets. There's this one here. Okay. Then there's. Come on. Outside first. Real briefly. A couple multiple choice questions. No problems.
What would a multiple choice be like?
Look at your quizzes. Those are the best. Those are the best.
No, for a simple machine.
Oh, like kind of, you know, like more of what kind of machine is this, but the real important part is that we talked about yesterday with the machines is the whole force distance relationship, right? That on one end of the machine you're going to have a long distance and a small force. On the other end of the machine you're going to have a short distance and a big force. That's pretty much the distance. That's important. Spray.
Yeah, I found the
That's the second one.
And then not conservative.
Yeah, not conservative. All right. We go with the first part. Okay. Then I don't see how you couldn't be crystal clear after that fabulous description that I just went through. It's thorough and very fluid. And, yeah.
Well done.
Next part that we talked about started the last week of the last grading period. We started getting into work. We said that in order for work, first our definition of work being a transfer of energy or a change in the energy of an object. And that in order to perform work on an object, two things are required. First, we have to apply a force to that object. Second, that object has to move some distance because of that force. And that's how the requirements that we get for force. After we introduced what work was, then we got into work energy theorem. And we talked about a non-conservative force. A non-conservative force being something that will change the mechanical energy of an object. We said pretty much everything out there is a non-conservative force except for two things, right? Gravity and then like springy elastic forces. Those two we categorized as conservative forces, and we'll talk about those in a little bit. Everything else, tension, applied force, friction, all those things are non-conservative forces and result in a change in the mechanical energy. Okay. Along with that, we did our first lab. That was when we went down to the PAC, rolled the marble down the ramp, and calculated the force of friction by looking at the difference between the kinetic energy at the beginning of that ramp, or beginning of the carpet, end of the carpet. We also did a couple of example problems in class that were very similar to that. Okay. So that's work energy theorem. Okay. Problem set, actually two problem sets for this section. One says work, it looks like this, and then the other one says non-conservative forces, work energy theorem up at the top. Okay. Answers to those are all posted online. Yep.
I have a question
Yep.
about for the conservative energy problem.
Yeah.
Like you use the mechanical energy formula, but is it only for conservative mechanical energy that you don't use the work part of it?
Yes. And hold on to that for just a second. Okay. So pretty much work energy theorem applies to everything except gravity. Okay. If you're pushing something, if friction is acting on something, if you're pulling something, any of those kind of problems are going to be work energy theorem problems. Okay. If it says like frictionless or no air resistance or gravity only, then it's going to be a conservation problem. Okay, and we'll talk about that in just a second. So as far as work energy theorem, two problem sets. The lab we did, although I haven't given that back to you yet, most of you haven't turned it into me yet, so I can't give it back to you. And then a quiz. The quiz we took for this section is the one that had the picture of the zoo on the front of it. We talked about the deck walk. Right? Had the skid marks on the front of it. Remember? Yeah.
I got it.
Skid mark joke. Never mind, I guess. Maybe when you watch it later, you'll think it's funny.
This is being recorded.
Yeah, I know. But there actually were, like,
Yes.
a car coming to a stop on that quiz. So, anyway. Oh. It's like delayed reaction.
We lost stars.
Anyway.
Yeah.
What?
Oh, I got you. Yeah.
You really see what?
Really serious.
That's, no. The bottom of that quiz. With those cars.
Oh, no.
That one, yeah.
Oh.
That was what I was talking
Uh-huh.
Okay.
about. Sorry. Yeah, let's move on from there. That was... All right. Yeah, we're good with that. Then, last week, we talked about conservation of mechanical energy. Whereas all those other forces we describe as non-conservative forces, gravity and spring forces we describe as conservative forces. Conservative forces will not change the amount of mechanical energy something has. It will convert one form of mechanical energy to another, right? When something falls, it loses potential energy but gains it. Good thing that's on. I think we got that being recorded too. But, you gotta take care of it. What? Yeah, I did kind of. Gravity, spring forces will not change the total amount of mechanical energy, but will convert one form of energy into something else. So as something falls under the influence of gravity, it starts with potential energy. As it goes lower and lower, the potential energy decreases, but the kinetic energy increases. If there's nothing else besides gravity acting on it, the decrease in potential energy will match the increase in kinetic energy. Okay? Problem set for this section, conservative forces, conservation of mechanical energy. The quiz I just gave back to you, and the pendulum lab that we did last week. Yeah, it was last week. That we've been hopefully working on it for the past couple of days. I didn't grade them yet, so I mean, if you want to back to take a look at it, you can. I'm probably not going to grade them tonight. Maybe you just bring the tournament tomorrow. Then this week, 2 brief topics. On Monday, we talked about power. Power being the rate of energy transfer, so just work divided by time. Then yesterday, we quickly went through the machine stuff. And we said that the big thing there is the work in, work out, the relationship between force and distance. But we also went through the types of machines there so that you can talk, hopefully be able to identify some of them. Questions relating to tests? The test, I believe, is 37 points. Besides push-up. Good. Note card. Whatever you need. You have approximately 20 minutes left.
Work on labs.
So you can work on your labs. That would be a good use.
Let's
That
go.
would be a good use of your time.
Let's get
Or if
this
you have
done.
any other questions, practice stuff you want to do, that's fine too. Be productive.
Oh.